topic. If there is some problem regarding the network issue, then you can unmute, one of you can unmute yourself and you can justify whether you are able to see my screen or not. And if you are not able to get any particular point, then also you can unmute yourself and you can stop me there and you can ask questions. No problem with that. I am showing you the screen where this thing is written VAM, 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 and this is my today's. This is the topic which I'm going to start discuss today first of all. And this VAM, as the name has already been mentioned in my earlier class, this VAM is the method by which a transportation problem can be solved. Now, if you have the copy with you, then you write in your copy that the name of VAM is Vogel's approximation method. VOGEL apostrophe S, Vogel's approximation method. That is the name for VAM. Okay, it is not mentioned in the screen. That's why I'm saying this to you. Now, I wrote method 4. It is because already we have discussed 3 methods to calculate the transportation cost.
One, so can you please again
the name of the method is Vogel's. VOGEL apostrophe S, Vogel's approximation method. Approximation method.
Okay, thank you, sir.
Okay, now I am stating this method as method 4. It is because already we have discussed 3 methods for solving transportation problem. The first method is NWCM. As you can recall, the full form of NWCM was northwest corner method. Second method which I discussed is LCM, known as least cost method, or sometimes it is called matrix minima method. And the third method which I discussed is RMM, row minima method. But you can tell me, you can ask me that there was another method which you are supposed to do, that is a CMM, column minima method. So I will tell you that row minima and column minima are actually together being considered as method 3 because they are similar to one another. Whatever we do in row minima, we just do the same, we just repeat the same kind of thing with respect to the columns. So we actually do not look into these 2 methods separately. We can consider them twins. Okay, so therefore row minima or column, we always say that row minima or column minima, these are the methods. So I am considering either of these as method 3. And lastly, the method which I'm going to start now is VAM. It's called Vogel's approximation method. Also, if you can remember that I calculated the transportation costs, and the transportation costs were actually different with respect to these 3 different methods. If you can recall, the transportation cost with respect to northwest corner method, can you recall? Can you tell me what was the value? What was the value of the transportation cost with respect to northwest corner method? Any one of you? 1,000?
Yes, sir. 1 minute.
1,015.
1,015. Yeah. Okay. 1,015 was the transportation cost for northwest corner method, and for least cost method, the answer was rupees
814.
Yes, rupees 814, 814, and for row minima method, the transportation cost was
110.
1110.
Yes, rupees 1110.
Yes,
so all of you write these methods name and the corresponding transportation cost beside it in your copy, because right now I'm going to apply Vogel's approximation method to the same problem, and we are going to compare what particular value is coming and whether it is greater than these values or lesser or falling between the 2 values. We shall compare. So you write the first value as rupees 1,015 corresponding to NWCM, 1110 corresponding to RMM, and 814 corresponding to LCM. And let us now begin my Vogel's approximation method. Now in today's class, I have, since the note is already prepared and the methods are already being written over here, So I'm going to read it for you first of all, and then I'm going to show you the screen on which the problem has been. I have tried to solve the problem, but at any point, I shall suggest you. I shall suggest you that whenever I shall be discussing the methodology of the Vogel's approximation method, I shall give you time, and you will try to do the calculation in your copy. First of all, I have decided that I am not going to write using my fingers in the on the screen uh, at present, because it takes lots of time. But even if some people doesn't is able not are not able to understand, then I can use the white screen, but not right now. But whenever I'll be showing you the screen where the solution has been done, you try to, I will give you sufficient amount of time, and you will try to solve this by yourself, and the solution will be in front of the screen, so that you can just take hint from the solution. Okay, I'm going to help you, don't worry. I think in this way we can do it in a faster way. So let me see what happens, then we will accordingly decide. So the first step of Vogel's approximation method, just like its counterparts, is that we have to check whether the transportation problem is balanced or not. And by balancing transportation problem, I mean that the total of the availabilities on the right hand side and total of the requirements below, they must be same. So if they are not same, the transportation problem is unbalanced. Step number 2 says, if the transportation problem is balanced, consider the transportation matrix with all costs, availabilities, and requirements as well together, and calculate penalties as shown in the following. We are going to calculate some penalties. What are these penalties? I'm coming to that point. Since we calculate penalties in Vogel's approximation method, sometimes Vogel's approximation method is also known as penalty cost method. Penalty cost method, or sometimes people say it as penalty method. But Vogel's approximation method, or VAM, is mostly used in the domain of operations research. How to calculate the penalties? It is the next step. For any row, carefully observe, or you can write this particular step over here. For any row or column, select the minimum and next minimum element of that row or column and set their positive difference as the penalty of that row or column. I'm pretty sure that you are not understanding anything what is written over here until I show you the problem in which the thing has been done. But I'm suggesting you to write these lines in your copy, because when I'll scroll down, then you can take reference from what you have written in your copy. So you can easily correlate the things together. Okay, because I cannot share two screens simultaneously at a time. So you write this particular paragraph in your copy. For any row or column, select the minimum and next minimum element of that row or column and set their positive difference as the penalty of that row or column. In bracket, it is written, if there is a tie, then the difference of the two minimums will be considered 0. Okay. Also note that if there are n rows and m columns, then the total number of penalties will be n plus m. So first of all, I'm going to show you the calculation of these penalties corresponding to the, I'm going to make you understand what we say about these penalties. What are these? Okay. So I hope that you have written. Somebody please unmute yourself and tell me whether you have written this particular paragraph.
Wait a
Okay.
bit, sir.
Then you
We
just
are
give
all
me a
writing.
hint that you have finished writing. Then I am going to scroll down. Do not write
Okay, sir.
step 3 right now. I first of all, I'm going to tell you what are penalties. Then I'll again scroll up and I'll come to step number 3. So don't write step number 3 right now. I just write this paragraph. So for any row, for starting from any row, for any row, write up to n plus m.
So finish.
Okay, so I'm scrolling down. This is the problem. You see, this is the problem which I discussed in the first day of transportation problem. All the costs are given over here. These are the rows. How many costs are there? In total, there are 1, 2, 3, and 1, 2, 3, 4. 12 costs are there given, and these are unit transportation costs. These were the availabilities. You try to don't look at this bracketed portion, because after the calculation this has been done. So the actual availabilities were 7, 9, and 18, and the requirement or capacity were 5, 8, 7, and 14. You quickly copy this matrix in your, you write the matrix in your copy quickly. Do not write the penalties, because the calculation of the penalties have not been discussed. Just write the transportation matrix in total, in its totality. Roman 1, Roman 2, Roman 3, Roman 4, these are the destinations. 1, 2, 3, 4, these are the factories. And 1930, these are the unit transportation costs. 7, 9, 18 is the availability. Capacity are 5, 8, 7, and 14. And the step number 1 was that you will be able to apply Vogel's approximation method if the transportation problem is balanced. So before starting the problem, we just check whether the sum total of 7, 9, and 18 is 34, and 5, 8, 7, 14 is 34 or not. If the total of these rows and total of this column is same, then this transportation problem is balanced and we are in a position to start the problem. Now let me come to the point of penalty. So I have put a column on the right hand side named as penalty, and I have put a row in the below, which is also known as penalty. Okay, how to calculate the penalties? We have to calculate the penalties for each row and each column. And you see, I'm again scrolling up. It was written in this particular paragraph that the total number of penalties will be, if there are n rows and m columns, the total number of penalties will be n plus m. So you see, in this particular matrix, total number of row is 3 and total number of column is 4. So according to the rule, the total number of penalties must be 3 plus 4, that is 7. And now you see, there are in fact there are 7 penalties. 1, 2, 3, 9, 10, 12. These 3 penalties are for rows. 21, 22, 10, 10. These 4 penalties are for columns. So therefore 4 plus 3, 7 penalties are there. It is just aligned with what is written in the step number 2. Okay, so indeed the number of penalties here is n plus m. How to calculate the penalties? What is written? Let us see once again. It is written that for any row or column, select the minimum and next minimum element of that row or column and set their positive difference as the penalty of that row or column. If there is a tie, you can consider the penalty to be 0. Okay, so since we are going to calculate the penalties for each row, let us start with row number 1. In row number 1, the minimum element is 10. This is the minimum element. Okay, and this the next minimum element, I mean to say that the last but one minimum is 19. Next minimum means last but one minimum, that is 19. Out of this all these elements present in the row 1, 10 is the minimum, and before that 19 occurs. Last but one minimum is 19. So I am going to take the difference of these two, but the difference has to be positive difference. I am going to take the positive difference of these two figures. So the positive difference of 19 and 10 will be 9. And so I have written the penalty 9 over here. Let us go to the row number 2. In row number 2, the minimum element is 30. And last but one minimum is 40. So the positive difference of 30 and 40 is 10. So I'm writing here 10. In third row, the minimum element is 8. and the last but one minimum, or you can say the next minimum, is 20. Next minimum. Why do I say next minimum? Why do I use the word next? It is because if I am considering this 8 to be the minimum, let us put the cursor on it. That means 8 has already been considered. Out of the remaining numbers, what is the next minimum? So therefore it is called this is called next minimum, or you can say it as last but one minimum. Okay, so I am taking the positive difference of these two numbers, which is 20 minus 8, that is 12. Okay, all the penalties have been calculated with respect to the rows. Once all the penalties are calculated with respect to rows, we will come to the columns. Now we will do the same thing in the columns. The first column, the minimum element is, don't consider this to be minimum element because these are not the costs, these are the capacities. Okay, in the first column the minimum element is 19 and the next minimum is 40, so their positive difference will be 21. In the second column the minimum element is 8 and the next minimum is 30, so their positive difference will be 22. In the third column, the minimum element is 40 and the next minimum is 50. So their penalty is 10. In the fourth column, the minimum element is 10 and next minimum is 20. So their positive difference is 10. So all the column penalties have been calculated thus in this way. Okay. Now there was an option given in the step. It was written if there is a tie. Now, so far we have not got any tie with respect to the minimum element. If the situation comes, then I'm going to explain. Right now, I'm not saying anything about ties. If the tie occurs, then I shall explain what is to be done. Okay, so all the elements, minimum and next minimum element, were different, and therefore you can very well identify them, and you can write their positive difference in the penalty column as well as in the penalty row. So in this way, we have calculated all the 7 penalties for this transportation matrix. Once the penalties are calculated, then what we need to do? So I'm going to scroll up. I shall again show you this particular matrix, but let me read you will get the time to copy this particular matrix, but let us first see what is written in step number 3. Then I'm going to come to this matrix once again. Write the comment written in step number 3 quickly, from this word till this word respectively. Quickly you write this comment. What is written? Out of all the penalties calculated, select the maximum penalty. In bracket it is written which is associated with either a row or a column. Okay, if there is a tie in maximum penalties, select any one of them. If there is a tie in maximum penalties, select any one of them. Okay, that means whenever there is a point when there is a situation of about tying or tie in the numbers, then your choice is the arbitrary choice. You can select, if there are twin sisters or twin brothers, you can choose any one of these two. Okay, so this is the scenario actually. Consider the row or column corresponding to that penalty and identify the cell with minimum element. Consider the row or column corresponding to that penalty, means corresponding to the maximum penalty. That penalty means maximum penalty. And identify the cell with minimum element. Okay. This particular paragraph is already known to you because we have done it already with northwest corner method, LCM and RMM. We are to allocate minimum of availability and requirement there. Write the difference, strike out whichever of the two is exhausted, and consequently strike out the row or column if availability or requirement is exhausted respectively. This paragraph we have used several times in my last class corresponding to northwest corner method, as well as for row minima method, as well as for column minima method and least cost method. If there are any students who have not who were absent in my last class, then I have already shown given you the link of my classes which I have already taken. You just go to the link corresponding to the transportation problem. There are 2 links given, so you go through the video, you'll definitely understand. Okay, so we are going to, after calculation all the penalties, we are going to select the maximum penalty, and corresponding to that maximum penalty, if it is occurring in the row or column, we are going to identify the cell with minimum element. Can I scroll down?
So wait, sir.
Yeah, okay. Then if you are writing, you also write the step number 4 and step number 5. I don't have to scroll up one again later. So in step number 4, it is written, consider the resultant matrix. Resultant matrix means after deletion of the row or column, the matrix which is left out is called the resultant matrix. Consider the resultant matrix and repeat step number 2 to step number 3. We have to repeat the process and keep repeating until all availabilities and requirements are exhausted. So you have to repeat the process until unless all the availabilities and requirements present in the transportation costs are striked out. And then once you get the entire thing, you calculate the transportation cost. You calculate the transportation cost as per the rule, as per the formula given in the objective function. Value multiplied by the cost. Unit transportation cost multiplied by the number of elements to be sent from a factory to a particular destination. So once you are done with these paragraphs, tell me, unmute yourself and tell me, then I'm going to scroll down. My time is also running out. So I shall tell you about the time, and also once the session ends, you have to rejoin once again. I'll tell you, but you just quickly write these paragraphs. Then it will be easier for me to discuss the methods with respect to the given problem. Also, you have not written, only one student has written his name in the chat box. Others, please write. Meanwhile, you write your names in the chat box so that I can save the attendance. The countdown has already started. 2 minutes, 17 seconds left. Others, please write your names in the chat box quickly. 25 participants are there. So please write your names in the chat box. You will be getting again your time to write these paragraphs, because in the next session I'm going to show you this screen once again. So first of all, you write your attendance. If you write your attendance, if you write your names in this particular session, you don't have to write it once again in the next 2 sessions. Okay. So yes, I'm saving. You write, keep on writing, and I'm saving. One minute, 31 seconds left for this particular session. One minute, 9 seconds left for this particular session. You are getting enough time to write these paragraphs. You write it. I am not going to start the discussion of the methodology in this particular session because it is almost going to end. Immediately after this session ends, I'm going to rejoin once again, and then I'm going to start discussing the methods with respect to the given problem. Anytime the class may end. I'm not going to end from my end. So